Good morning again. Welcome to our webinar BIM for Bridge Design, or we can call it Autodesk Solution for Bridge Design. Just before we start, just a couple of things as a logistic for the webinar. So please, you are muted, and please use question pane to put your questions, which I will answer at the end of the presentation. What I want to say is that I will not be following each and every question as they are popping up. I will go to them at the end of the webinar. So, but please don't hesitate to write your questions, and I am happy to answer that. So before I start the presentation, my name is Tomáš Lenvorský. I am Senior Technical Sales Specialist for AEC in Autodesk, based in Prague, Czech Republic, and being responsible for Eastern Europe. So you can see my face, and I must say that my face is this one at left bottom corner of the slide, not this one on the right hand side, just that you know who I am. So with that, I will start my presentation. So Autodesk has very wide portfolio, and we can cover infrastructure part of the task, we can cover architecture part of the task, we can cover building part of the task. And we can also cover, maybe you don't know about this, media entertainment, which means that we are very good also in gaming engines, etc., which also help us in architecture infrastructure for visualization, augmented reality, virtual reality, etc. We do have also a portfolio which is helping us for collaboration, and I will mention later on during the presentation BIM 360. We do have also portfolio for construction part. I will not mention it here on this webinar, but please bear in your mind that we do have a construction portfolio, and this might be a topic for some next session. And having this wide portfolio is really helping us to do a lot of stuff as far as design is concerned. And if we are talking about infrastructure design, we can cover not only road design, but having also a good portfolio for architecture, so we can cover also structures which are on the road or on the infrastructure, which can be bridge, which can be retaining wall, which can be tunnel, etc. And the goal of these webinars to show you how we can solve design of the bridge. And what I want to state also at the very beginning, that I will be showing a number of the solution from our portfolio. However, you as a user, you can use only part of it depending which part of the design you are doing, and I will be mentioning it throughout the presentation. And we do have a portfolio which is covering entire process from design to build and operate, which I mentioned at the beginning in the previous slide. However, we are at this point also talking about connected BIM, because it is obviously very important that you are designing something in 3D with additional information, which means you are doing something in BIM. However, what is also very important, that you are working with connected BIM, that you are not working on your computer only, but you are sharing your design with other people, that they can benefit from what you have designed, and which information you added to the system they can use as well. So this is why we are talking about connected BIM, and we do have advantage of a cloud-based solution where you can seamlessly post your data, and people can use it in other steps. And as I mentioned, we are talking about, I will be talking about bridge design, and obviously there is a lot of different bridges. There is concrete deck bridge, concrete box girder bridge, concrete eye girder, steel truss bridge, and so on and so forth. And obviously within this webinar we do not have time to cover each and every type of bridge. So what I will do, I will focus on concrete bridge design, and you will see how we can do concrete bridge design, and this workflow is later on applicable for other types as well. So as I mentioned, I will be talking about concrete bridge design workflow, and I will be talking in fact about real bridge which has been already designed. So I will be talking about flyover which has been designed across existing junction, and you can see that this bridge has been already built. It's already constructed, and it is a bridge which has been designed in Netherlands. So this is not just a kind of fake story, but it's a real story about a real bridge, and you will see how people were using our portfolio to do bridge design. And as we are talking about BIM, or better said about 3D dimensional design, where you can add more information, we are also talking about different stages of the bridge design, and this is starting from conceptual through detail road design, bridge design, and bridge detailing. And we do have different products for these stages. However, what is important, and you will see throughout my presentation, that our products can communicate, and you can transfer data which you will create, for example, in conceptual design of the road. You can move it to the detail road design, and the data which you will create in detail road design, you can move to the detail bridge modeling, and so on and so forth. So what is also important to understand, that Autodesk is taking care of how the data are seamlessly transferred between different products. And what is important is that you are using the same data in each and every stage, and you are in fact just enriching the data with new information. And you might ask maybe why we do have, for example, here you can see Civil 3D, you see Revit, and why we are not using one product for everything. The reason is that, for example, a road designer, he has a different view on the bridge than the bridge designer. So this is why we do have to have different products for different personas within the process. However, obviously in Civil 3D we can also design the bridge, but again this is the bridge from the perspective of the bridge designer. So there are not as many details as Revit, as the guy who is using Revit, and he's the bridge designer. This bridge designer he is using because he needs to produce different drawings, different outputs, different reports, etc. And you will see it throughout the presentation what we can do with that. Now let's have a look for conceptual road and bridge design. So at the very beginning we have a possibility to create quickly concept of your bridge, including roads. So here is some ramp which will be followed by a bridge, and then again some ramp. And now I am using a product called InfraWorks, and the big advantage of this is that the data which you can see here at the background are 3D data of the terrain, plus imagery of the terrain, orthophoto, plus 3D buildings, and all this can be created very quickly for free using cloud services, and you can get some data which are, for example, displayed here in couple of minutes throughout cloud solution. And then based on this real 3D data, you can start to design concept of the bridge. But concept of the bridge for us also means to add geometry. So you have to know what, or you want to design what are the radiuses, what are, for example, super elevation of the bridge, and you will see now I will specify, okay, my bridge will go through some points, so I will define how the bridge will look like, where it starts, where it's finishing. I can design even piers. I can move these piers that they are making sense, that because I'm doing design of the flyover across existing highway, so that the piers are not interfering with existing roads. So we do have possibilities to quickly accommodate changes, and obviously we are in 3D. System knows about not only about the bridge, but system also knows about the existing ground, existing roads, and we can check things, for example, like minimum envelope. So basically, if the cars will be it will be possible to pass under the bridge. And now, if I specified clearance, so I can also accommodate the profile of the road based on this envelope. So very quickly, system changed the profile of the road, and now I am sure that cars will be able to pass under this bridge without any problem with defined height 7 meters. And we can get, for example, even quantities at this point, and we can do much more analysis. We can do, for example, sweep path analysis, minimum side distance analysis. We can do also visualization and so on and so forth. But what I want to do is I want to focus more on a detailed design. However, I wanted to give you understanding what's going on. Even though I mentioned that I will not be answering the questions, here is the question: if I can change some of the elements of the bridge, like pillars, piers, etc. Yes, it's all parametrical. We do have some predefined library of the piers. However, you as a designer, you can design your own elements of the bridge as you wish. So let's move forward. We have conceptual bridge design, and now we can move to the detailed road design. So road designer now wants to define the bridge, no, sorry, the road, and what he wants to do, he wants to use what has been already designed in conceptual stage. So he is opening the empty drawing, and at the background system automatically displayed maps so that he knows, the designer knows where he is. And now he is bringing data from the previous stage to the new stage, so that he has the very same model of the road. But not only this, he knows also what is the bridge. For example, here this was done. And later on we will move to the bridge design, to the Revit, so we can use obviously the very same ground model within Revit as well, within the next product. But road design, let's focus on the road designer. So road designer can design the road, the width, the super elevation and everything. And then later on the data which has been designed by road designer should be used by bridge designer, because bridge designer knows, okay, the bridge will start in this station to that station, super elevation is something like this, the width is something like that, and we can export the data X, Y, Z, super elevation, etc. to the Excel sheet. And this Excel sheet will be used later on for detailed bridge design. So let's have a look how we can do this. With bridge modeling, we are moving to the next product, and the next product is Revit, because this is our flagship product for structural design on the infrastructure project. And let's have a look how we can use this product to design, for example, bridge. So what I will do at the very beginning, I will create what we called family. And this is something like very similar what you do maybe in AutoCAD, designing or drawing the typical cross-section of the bridge. However, here we are using constraint because it's parametrical modeling, and we are defining constraints, how it should behave, which dimension should change. If, for example, left edge of the road will change, then automatically right width of the road will change. The same is the super elevation. So we are defining constraints, we are defining points, and then we are defining links between these points. And this is really parametrical family which can be used within different products, and you can see that if I change some variable within this template, then entire model is changed. So it's really parametrical, and it's a big advantage that you will draw this typical cross-section just once, and then it's automatically modified. So let's move, and what I will do now, I will create a new project where I will place this what we called family, and what I will use at this point is Dynamo. Dynamo is visual scripting programming which helps us at this point to connect the world of road designer with the world of bridge designer. So what I will do is I will read this Excel sheet and I will tell to system which columns, which coordinates should be read as a X, as a Y, as a Z, as a offset, and system will automatically create for me the bridge. Better said, the lines which are defining the bridge. These are exactly the same lines which road designer designed. It is center line, left edge of the road, right edge of the road, and maybe even more edges depending on the complexity of the bridge. So having this, we have these lines, and we have them obviously in Revit. Dynamo is just linking this Civil 3D and Revit. Then I'm placing this typical cross-section, which is parametrical family, as I mentioned at the beginning. And now I am telling to system now what I want is that this typical cross-section will be hooked to these lines, and you saw it that system knows what to do, and system will apply automatically the width of the road, the super elevation of the road based what has been done by road designer guy, and the very same model has the bridge designer, and he did what we call solids, and these solids are based on what road designer is. However, because it's parametrical, even the bridge designer can change some of the parameters, and you saw I changed, for example, cross fall in 2 points. So I can do this. It's my decision if I want to do this or not, and I can change the width, height, etc. So with that, we can have within the Revit, within bridge designing tool, very same model as we had in as a road designer. Now let's move forward. We have what we call superstructure of the bridge. What we want to do is we want to place the bridge elements. Now what I will show you is how we can place these piers manually. So what I have here is this superstructure, and I am defining where the piers should be. Obviously it can be, for example, read from Excel sheet, from other sources, but now I am doing it manually. I'm specifying where it will be. And what I will do is, okay, I just changed the visibility of some element that I don't want to see something that is clear to you what I am doing and where I am, just making something visible and invisible like what we are doing in AutoCAD. And now I'm placing again family. It is intelligent object which will react on the height of the superstructure and the level of the ground. And I can specify here height, and this is the advantage of parametrical modeling, because as soon as I'm changing, for example, height or type, system will accommodate automatically these changes. And I can do it manually, and obviously if you have some longer bridge, it may be time consuming. If you have short bridge with 2-3 piers, no problem. But with the longer bridge, it can be time consuming, and this is why we have also possibility to automatically place these piers. But again, I want to stress, this is just option. This manual functionality is always there. I just want to show you how it can be automated. And again, I will start with the same drawing. I will make some elements invisible, that you know, and visible, so that you know where we are. I have this existing ground. I have these elements coming from Civil 3D. And now what I will do, I will use again this Dynamo, this visual programming language, and I will call script which can automatically place the piers. Please be aware that these scripts which I am talking about here are all publicly available. You don't have to program anything. This is something which you can download and which you can use as you go. What you have to do is, or if you are defining something, obviously, what is needed for this pier placement. I need locations, so I specified where the piers will be. And so these are these points, so just visually where these points are. And then obviously what I need is, I need elevation of the superstructure, where the piers will have the top limit, elevation limit. And also what I will need to specify is where is the ground. And the rest, this script will do automatically. So I specify where is superstructure, where is the ground. So system will do everything. I will not need some automatical placement, manual placement. I will just later on hit one button and everything is done. So you can see that these piers are already there with all information, with height, even with what we call mark. Basically, we can specify when it will be built, that we can create later on easily construction sequences. So again, this is one of the possibility. For your information, Dynamo is automatically embedded in Revit, in product which I'm presenting at this point, and you can use these scripts which are available as we go. So, and then let's make it more complicated. We have superstructure, we have piers, and what we need to place bearings under the between the superstructure and pier. So how to do this? Again, you can do it manually. So this bearing is in fact family, and you can place it, one by one. However, I can again call Dynamo. I can call script which is available, bearing placement, and you will see how efficient it is, because what I need to specify, superstructure, I need to specify where are my piers, so I will select all of them in one go. So system knows about all elements, and then selecting superstructure, so that system knows in between which elements I want to place it. And now I will define how many bearings I want to place here. So now I placed 6 bearings. But what I can do, obviously having script, I can change the number to 4 and immediately as you go update it. So you see that we can automate the process, and you can get results very quickly. We were talking about superstructure, we were talking about piers, and what about abutments? Again, being in Revit, so we can create very quickly abutments as a family. And these families can be again later on used within other projects. So it is not part of one project only, but because you are creating intelligent family, which is in fact we are modeling at this point, so with all constraints, with all parameters, then obviously you can take it and use it within different projects, and you can increase your efficiency very significantly. Obviously, at the beginning, maybe you have to invest a little bit more time to create it, but later on you will benefit from all this information which you already created, and you can use it again and again. And obviously, if you are part of some bigger company, so there might be one guy who is dedicated to create these families, and the rest can just consume these families, and they just have to learn how to use it. So I will say it's kind of similar like intelligent blocks in AutoCAD. However, here the intelligence is far much bigger, and you will see the benefits modeling something like this later on, because this is something where we can go and we can benefit from the model. And now what I will do what we call construction parts, because the bridge will not be built as a one piece, but in some segments. So I can specify what will be the gap between these sections. So here, for example, I specify 80 millimeters, and immediately it's the bridge is cut it into these pieces. Obviously, I can annotate what is the gap in between this for this, and I can specify obviously the different value. And again, I'm benefiting from a parametrical model where one change can be propagated throughout the entire model. And we can produce the drawings where you can display how it will be built in which phases, etc. And not only this, we can do later on visualization. I was talking here about connected BIM, so here is the big benefit of cloud, because this rendering can be done in cloud, so you don't need to have some very powerful machine to make such visualization, but it can be sent to cloud system. We will do calculation for you, and we will bring you back this visualization as you wish. So now I will finish with bridge modeling, and let's go to the details for reinforcement, for rebar modeling, because having a 3D model is excellent, nice, we can do a lot of things, but what we need is we need to do some reinforcement, maybe some details, some detailed drawings. And for this we will use the very same product, Revit. And in some points I will use add-on from Sophistic, which you can download from our Autodesk application store, and you can use it if needed. I don't want to say it's needed necessarily, but you can see that it's another option, and it's really just add-on on the top of Revit. And we will do rebar setting, then we will do rebar modeling, we will do rebar annotation and documentation. So let's have a look. What we need to set up templates. So before you start modeling rebars, you should have a short look how important are settings for all reinforcement. For example, to include hooks in rebar shade definition, as well to include end treatments in rebar shade definition should be defined before any rebar is placed in the project. So you can do this. Then also, if you are talking about rebar definition, you can place rebar in any 2D view. So you don't need to create some specific drawing where you will place the rebars, but you will use just a drawing which is already created, and you will place your rebars, and you will have different modes, and you will see it later on live how we can place these rebars related to existing elements. And what is important is when we were modeling the bridge, we were defining how if the shapes which we created, which means superstructure, piers and abutment, can host the rebar or not. And we said yes, we can host the rebar, and you will see that we can benefit from this. And we are going even to very detailed. So we are going to reinforcement modeling of the connectors. And again, this is these connectors are family-based and fully customizable elements. And each team member can use them according to their needs. So if you are, for example, structural engineer, you can use this schematics or connector to define the requirements. For example, detailer can use them to produce, for example, shop drawings. And manufacturers can go into the full detail, and they precisely model and represent their enforcement connectors to create installation instructors. So we go to very, very detail, in fact, as far as modeling is concerned, and you can do a lot of things. So let's have a look how we can do this. We do have these piers. These are 3D models. Obviously, we can create sections. You have a plan view, section view, and now I'm placing the rebar. So, and now I can say, okay, I want fixed number or maximum spacing. So this is kind of a family, and then I will just stretch these rebars. And because system knows that this element can hold these rebars, so these rebars are automatically adjusted in sizes. And again, it doesn't make any difference where you place the rebars. At the beginning, I placed them in section. Now I will do it in plan view, and I'm selecting from the library different rebars. So just changing parameter, and the rebar is changed. Specifying again maximum spacing, and system will automatically stretch these rebars into the element. So this is when we are really benefiting from 3D model, having full 3D model of a bridge where we can do really nice details. And also remember, this is not only drawing, it's a model. And these rebars, they can have parameters like, for example, weight, so that you know later on how much weight is needed or will be placed to some piers, etc. So you see that you can specify how these rebars will be placed parallel, perpendicular, and system knows about the constraints, about the shape constraints, and you see just really simple shifting, having some parameters. I can do this very easily. And very similar with abutment. You see, I can produce really detailed reinforcement of abutments of the piers. Then how to annotate it, how to create some drawings. So having 3D model, it's nice, but obviously the end of the story is to create drawings. And we can do this. We can annotate it, so we can annotate it one by one as a multiple segment, adding some text. And again, all this information has been added as we were designing. And now we only getting information from within model, which definitely eliminates the mistakes, user mistakes, which rebars should be used, which we used before, how to annotate, etc. Everything is done automatically. And what we can do also, we can draw some details, how many shapes of this rebar is there with other information, so you can do very easily table, and we know what are the sizes, where they are, etc., and so on and so forth. So you can do really, really detailed drawings which can be used on the construction. What we can also do is we can do schedules, which means that having 3D model is not only about 3D model and nice drawings, but also about information about bill of material. And it's up to you how the bill of material will look like. So you are just specifying which information should be taken from 3D model, quantity, for example, weight, etc. as I mentioned. For example, here you can use some formula to define the weight. And at the end of the day, you will have this schedule, this bill of material, which is again dynamically linked to your 3D model. As soon as you will change something in your 3D model, this bill of material is automatically changed based on these changes. So again, a huge benefit is eliminating errors and mistakes. And I believe you will agree with me that if you are doing some project, there is many changes as you go, and what you need is to have really dynamic tool which will automatically update based on different model drawings, bill of materials, and all deliverables which you need to deliver to other parties. So what we can also do is as I showed you, we can do it manually. So we can manually place the rebars. I just want to show you is what is also possible, and this is using Dynamo. We can place these rebars automatically, which means again using computational design, system will do it for you using script, which is again available. So what I will do, I will just create the name for this element. I will call the script from within Dynamo, and what I need to say to system, which elements, which model elements should be rebar, and which kind of rebar I want to place. And as simple as that, without any delay, system knows about the shape, he knows what to place there, and the rest is done automatically. And obviously I can do it for the rest for different parts of the superstructure. So having possibility to specify also not only rebar type, but how it will be hooked at the start, at the end. So all this information can be done. And again, this is model which you can later on change as you wish. Dynamo just help you to place it automatically, nothing else, and the rest, with as far as drawing are concerned, as far as bill of material is concerned, everything will be possible with this approach as well. So again, Dynamo is option only. You don't need to do this. If you want, you can place it manually without any issue. And then obviously you can create deliverables drawings. So we did detailed design of the bridge, including reinforcement. Let's move forward. Let's look to construction management. What I want to show you is multidisciplinary coordination, because if you are working on bigger project, you can be supervisor of this project, and you want to use some other products where you can aggregate the data from different sources and being able to make quantification, clash detection, make markups and sequences. What I want to stress is, for example, coordination or quantification, we can do it with Revit. It's not a problem. The reason why I'm showing you at this point Navisworks is that if you are main engineer of the project or supervisor, you don't need to know each and every product like Civil 3D or Revit or different tools to make, for example, clash detection or sequencing. We have one product which is capable of doing all this stuff, which is very simple, very easy to use, and in fact dynamically linked to the source model. So let's have a look to the coordination and clash detection. So we can bring our bridge to Navisworks, and then we can create clashes. So I am supervisor, and now I'm, or better said, main engineer of the project, and now I will say, okay, I want to check rebars of some sizes against the rebar sets of some different sizes. So if there will be clashes, And obviously my model is prepared the way that there are some clashes, and the system will automatically highlight these clashes. You don't have to search for them. You will just say dim others or display others, and just switching between the clashes, you will see where the clash is. And what we have is what we call a switch back, and you can switch back to Revit. Revit will highlight exactly where the problem is. You can change the Revit model, which is for us what we call authorizing tools, and updating Revit model and saving it will automatically update the model in Navisworks. So again, there is connection between these two products, and not only between these two products. For example, the same applies to Civil 3D, etc. And all this information in Navisworks are up to date. Another possibility is quantification. Again, you can do it in Revit or in Civil 3D or other authorizing tool, but if you want quickly check bill of material or calculate something, for example, formwork, so you want to know how much formwork you have to place on these cups, on these cups which will be in situ concrete piles, so you can do it automatically from model. So very easily you can select all pier caps in one go, and you will place it to the appropriate item in your quantification model, and you have not only, for example, volume, but you have, because we put some calculation, we know also what is the perimeter of this cap and how many meters of formwork you will need. And now you can export this bill of material, for example, to Excel sheet, and you can send it to somebody on the construction site that he knows how much is needed for this particular task. And last but not least is construction sequencing. So having all this information in Navisworks means that we can do what we call sequencing. This sequencing can be done manually, like here, or automatically connecting it, for example, to Microsoft Project. So somebody already did sequencing in Microsoft Project, so we can pair it or map it to our 3D model, and we can show how the construction will look like in sequences. And you can freely move within the model. You can stop it in any moment. You can look how it will look in day. Here on the top you have Wednesday, Tuesday, etc. How it will be constructed. You can stop it. You can show it to other people, and you have much better understanding what's going on. And what you should understand, we can create, for example, construction, but also demolition, so if something has to be destroyed or some temporary work, etc. And at the beginning, when I was talking about BIM, I was talking about connected BIM, which means all the information which you are creating can be shared with other stakeholders. And we do have services which are cloud-based and which are helping you to share your model with people on construction site, wherever they are. For example, here they can have a look and they can check your design on mobile device. They have access to all information which you did as a designer. So he knows what material is there, etc. But on the construction side, what he can do, he can make some markups to give you information that something is not correct. He has access to all drawings. He has access not only to 3D model, but also if you created 2D drawings, he can mark up also these 2D drawings. So he can do it very easily. And then if you are in office, through cloud, you can connect to the very same data from your desktop. You will open only your Internet Explorer or any Explorer which you are using, and you can see all these markups using comments. You can click on it, you can reply. So, and all these information are stored. So there is no discussion if you received mail about this clash, if you received mail about this problem on the construction site. No, everything is located in one source of truth, and everybody can see what's going on. And you already saw it, you can review a model in web. Basically, no need to install anything. You can open and you can work with this, and you can review anything, and you can add more information. And what is also important, what I want to mention is that we are keeping versions. So basically, as soon as you are adding new version of your design, what you can do is you can just upload it to the model, and everything is updated, and in cloud we are keeping different versions of your design. And last, what I want to mention is, for example, planning and logistics. Just show you how the 3D model can be used. And what we will do is we will use here the product which I showed at the beginning for conceptual design, where I was showing how the bridge is easy in conceptual stage to design. But here, the very same product we can use for what we call planning and logistics. Basically, you can plan how, for example, there will be some detour of roads, you know, so that they will merge to some temporary road or to some side road. And what is the big benefit that we can use what we call different proposal, but it's a different variants of your construction, and you can communicate how the construction site will be developed throughout the time. So we have the same model with different phases, and just switching between these phases, you know if there are piers, if there are no piers, etc. And then very easily you can define that you can drive through. So you can say to system, okay, now I want to have experience of the driver at this level of development of my construction site. So I can pass through this very easily. And the point is, I can do also it for this side road. I did it for main road, I did it for side road. But the big benefit is that everything is one model. What I will do after driving through this sequence, I can just simply switch to different proposal, where is the different level of development of my construction site. System will just change the model at the background, and I can drive through again with the same settings. I just see something else, how it will look like in day, I don't know, 55 of my construction, whatever, when there will be different piles of materials, of earthworks, some fences, some construction vehicles, etc. I can create videos and I can share with somebody, or because we have cloud at the background, you can publish all information to the cloud, and other parties can just open the link which you will provide them, and they can have a look to the construction site so that they can see how it will look like in the particular date. So they don't have this model, they just have what we call 360 views on a model, and they can rotate it and they can see how it will look like. So, and again, the model at the background is a rich 3D model of existing roads and buildings, has been created very quickly in a couple of minutes using cloud services. Just want to remind you what I mentioned at the very beginning. So we just edit our design into this rich model. So with that, it's 9:53. So with that, I'm opening the questions. So in fact, there was already one question which I have answered. So please feel free to write questions that I can answer it. And what you can see here, if you don't have questions at this point? Okay, no problem. If you have later any question, please do not hesitate to contact me. Here you have my email address, but what I put here also is address of colleague of mine, Viorel. He is a guy who will help you if you have any question as far as business is concerned, which means I'm the technical guy, Viorel is sales guy, and he will give you information what are the prices, how licensing model can look like, etc. So if you have a question in this respect, please do not hesitate to contact Viorel. And what is important to say is that Viorel is Romanian guy, so he can speak Romanian, not like me who can speak just with Chenglish. So Viorel will help you most probably much better than me. So still waiting for any question? Well, if there are no questions, it means that I was so crystal clear that everything is really understandable and you have something like this. What I want to stress, please, I gave you a really wide presentation of our portfolio. And please, we are ready to discuss with you what is important part for you, because I understand that most probably you are not covering entire process. But we are here ready to help you to get up to speed and being ready to start to use it. I don't think that at the very beginning you will immediately use Dynamo, that you will immediately use rebar, reinforcement, etc. Obviously there will be some steps, but the first and very important step is that you will move from 2D to 3D and you will benefit from this parametrical modeling, being able to very quickly create drawings, bill of materials, and not only being very quickly able to create it, but also if there is any change, you will be able to change these, you will be able to incorporate these changes very quickly. Yeah, here is one note that I throw at you a lot of information. Yes, you are right, Alex, I agree with you. However, I wanted to give you overview what's going on. And this webinar is recorded for all of you. So here you mentioned that you want to go slower through this. Yes, you can in your own pace, you know, so you can have a look. And what I want to stress, this is not training. Don't expect that after watching this webinar you will be able to use each and every product which I presented here. Obviously this is why some training is needed, so where our partners will be very helpful and they will help you to get up to speed. The question is if we will integrate Dynamo in Revit. Well, it is already integrated. This is part of Revit. You will just install it as an add-on. It's in ribbons of the Revit. In fact, Revit you can also, if you are not Revit user, you can purchase separately what we call Dynamo Studio, and this is used also in different industries. For example, automotive industry is using also Dynamo, so there will be most probably always standalone version of Dynamo in the future. But again, Dynamo is integrated part of Revit. You will just install it as an add-in. It's part of Revit, and you are running it throughout from within Revit. So, more questions? if there are some issues, I mean compatibility issues between Civil 3D and Revit. In fact, as I showed you or as I presented, we can use the same 3D terrain model which we are using in InfraWorks, which we are using in Civil 3D. It can be used in Revit. This is not the issue. The horizontal and vertical alignment and profile, basically where the road is going, what is the width of the bridge, etc. There we are using Dynamo to connect these two products, Civil 3D and Revit. And in fact, I see it as a benefit because then you are not only limited to use, for example, Civil 3D. You can get the design from somebody else who is using some different product, and you can bring this information to Revit and being able to really model your bridge based on any road designing information. BIM integration, BIM coordination, I mean. Well, if you are talking about BIM coordination between Civil 3D, Revit, in fact, I would suggest to bring all information to Navisworks, being able to really coordinate everything in one model. There is Navisworks to do this. Basically, the road designer will do his part. He will do these ramps, cut, fills, etc. And bridge designer will do his bridge. And then everything can be moved to Navisworks. However, we can bring the model from Revit back to Civil 3D. It's not a problem, maybe later on to make sections, etc. So this is also possible. There is different variants, and it really depends what you want to achieve, and maybe it's more for one-to-one discussion what you want to achieve. If Navisworks works with Civil 3D and Revit models, yes, and we have what I mentioned during the presentation. If the question was if Navisworks works flawless with Civil 3D and Revit models, yes, it's not a problem. We can bring together models from Revit, from Navisworks, sorry, from Civil 3D to Revit to Navisworks model. And don't forget, later on, what you can do, you can use underlay of Navisworks within either Civil 3D or Revit. So basically, you can bring back model to original. Better said, you can bring back this coordinated model back to authorizing tools like Civil 3D and Revit, and you can use it with this extra functionality. Another question is if you can have a look to Dynamo script which I was presented. Yes, there is a Dynamo library, Dynamo script library which is publicly available. These scripts are there. However, again, what I would like to stress is without proper training, I am not 100% sure if you will be able to use all these functionality. So I would strongly suggest to contact our partners and to have discussion what is needed as far as training is concerned. But yes, again, this is publicly available and you can use them. But I would strongly suggest to have training, and not only for Dynamo. I would say the Dynamo is last bit of everything. First, you need training on Civil 3D, on Revit, if you want to use Navisworks, InfraWorks, etc., depending on what you want to achieve, and then you can start, and then as a next step, maybe Dynamo. Here another question which I just overlooked. if you need, as far as reinforcement is concerned, if you need to install anything. No, you don't need to install anything. So this reinforcement is part of Revit. The only thing which I mentioned during my presentation is that for annotation purposes, you can you can use this sophistic add-on, which can be downloaded from our App Store, and this is just one thing which you can which you will have to install. Other than that, this reinforcement functionality, modeling reinforcement functionality, is part of Revit. So, any other question? It's 10 o'clock. People are already leaving the session, but if you have any question, please do not hesitate to ask me. I will be here still a couple more minutes, so if you have anything, please don't hesitate to write any question. With that, I will stop recording.